In this video, I will be explaining you the derivation of Lagrange's equation for a conservative system. Okay, if you look at this notes, you will be confused. Okay, don't feel like studying. Okay, so that what I did is I made a beautiful note for myself, and I will show you that to you also. Okay, to make your learning easy. Okay, here you can see the derivation of Lagrange's equation for a conservative system. So we don't want to write these big paragraphs, okay, because nobody is going to read that in your exam paper. Okay, in examiner will have, or not examiner, the person who corrects your exam paper will have only the keys, not every steps. Okay, so without knowing what it is, if you study, then that's very difficult, right? To keep that in your mind, you feel very difficult. So I made a beautiful note so that you and I feel easy to learn these derivations. So here you can see first what you have to write is, this is the derivation. Let T is the total kinetic energy. I told you, capital T, kinetic energy is denoted by capital T. Okay, so let T be the, you have to write this sentence, let T be the total kinetic energy that depends upon these. Okay, if you want to know what these are the generalized coordinates. Okay, you can also include this also in your sentence. That is, I will tell you how. Let T is the total kinetic energy that depends upon the generalized coordinates this, and let V be the total potential energy. So potential energy is denoted by capital V. Okay, this is also a basic thing that you have to know. Let capital V be the total potential energy. We have write this, don't forget this line. Okay, we have minus V is equal to pi. You are multiplying with the delta on both the sides so that you will get this. Okay, now you are differentiating V and differentiating pi. Okay, the same in the way that I explained you in another videos that you can see in calculus of variation and integral equations playlist. Okay, go and check out my playlist if you want to know or if you want to see those videos. So here how we are differentiating this is, if you don't know that trick, then you will mug up this, try to mug up this, so you feel confused, and at the time of writing exam, I'm sure that you will commit mistake in these. Okay, so I will give you a short trick to write these without any confusions. Okay, so here first you are differentiating this V, right? So just write this V and and write the generalized coordinates like this. Using this you are going to write, so dou V by, you can check. Okay, I am going to tell using this. Okay, you can check this whether I am saying it right or not. Okay, dou V by dou Q1 into delta Q1 plus dou V by dou Q2 into delta Q2 plus etc. Dou V by dou Qn into delta Qn. Put this equal to, and here for this, in the place of V, now you are putting pi. Okay, here you can see that pi, and write the generalized coordinates, and using this you are going to write this, dou pi by dou Q1 into delta Q1, dou pi by dou Q2 into delta Q2 plus etc. plus dou pi by dou Q1 into delta Q1. Okay, so you will write this. Now you are multiplying this minus so that you will get this. Okay, right hand side of this will be the same as it is in the previous step. Now here what you are doing is you are putting in the place of minus dou v by dou q1 and dou pi by dou q1 dou pi by dou q1 you are putting capital Q1. Okay, capital Q1 into delta Q1 plus capital Q2 into delta Q2. Okay, instead of these values you are putting Q1 Q2. Okay, where you are writing what is Q1, what is Q2, what is Q3, etc., what is Qn. Okay, so this is Q1. What is Q1 value? This minus dou v by dou q1 and dou pi by dou q1. This values, okay, instead of these values you are putting q1. You are denoting q1 is denoted, these values are denoted by q1. Similarly for q2, q1, etc. After writing this, what you have to do is the quantity. Here you have q1 delta q1, q2 delta q2. In general we are writing the quantity. This is a work done by the forces in the displacement delta qy. You have to write this in it. Now you are using Hamilton's principle for conservative systems. So this is the Hamilton's principle to conservative systems equation. Memorize this. The associated Euler equation is, you have to memorize this also. Okay, now what you are writing is since here dou v by dou qi dot value is 0. Okay, so you don't want to write that here. Other than that you have to write all other terms. That is, from this you are writing d by dt dou t by dou qi dot. You don't want to write dou v by dou qi dot term because the value of that is 0, right? So just skip it and then write minus dou t by dou qi minus dou v by dou q. Sorry, not minus. This minus and minus becomes plus. Okay, that is how you will get plus dou v by dou qi is equal to 0. Now by using star, what is our star? This, right? These values. So you are using that here in the place of dou v by dou qi. You are substituting the value dou v by dou qi is equal to minus q1, right? Your minus is coming to this side because the value of dou v by dou q1 is needed and that value is minus q1. So here you just substitute the value. Here in general for qi you are writing, so you are putting minus qi here is equal to 0. Now plus and minus becomes minus, and from this bring this qi to this side so that you will get this, and this is called the Lagrange's equation. This is our required Lagrange's equation for conservative system. So hence our derivation comes to an end.